Imagine you are standing on the edge of Valles Marineris, watching a blue sunset fade into a dusty copper sky. You have successfully crossed 140 million miles of void, landing on a world humans have dreamed of for centuries. It feels like the ultimate triumph of our species. In reality, it is a biological dead end. The obstacle isn't a lack of fuel, nor is it the multi-billion-dollar price tag or the fickle whims of politicians. The true barrier is written in your own marrow. Once you step onto the Martian surface, you aren't just a pioneer, you are a prisoner of physics. The tragedy of the Mars mission begins with the silent thinning of the human frame. On Earth, every movement you make is a battle against 1 g of gravity. Your muscles are constantly under tension, and your skeleton acts as a reinforced load-bearing structure. Mars, however, offers only 38% of Earth's pull. The body is a ruthless accountant of energy. If a system isn't being used to its full capacity, the brain simply stops investing in it. Within weeks of arrival, your body begins to shed its own foundation. Density every single month. To put that into perspective, an astronaut on a 2-year Mars mission would experience bone loss comparable to a 70-year-old suffering from extreme osteoporosis. Their skeletons become porous, brittle, and glass-like. While your bones are turning to chalk, your heart is literally changing shape. In a low-gravity environment, the heart doesn't have to pump nearly as hard to move blood upward to the brain. It stops being a powerful muscular pump and begins to atrophy. It shrinks. Over time, it takes on a more spherical, less efficient shape. This isn't just a temporary adjustment. It is a fundamental remodeling of the most vital organ in your body. What happens when this shrunken heart and these brittle bones are suddenly exposed to full Earth gravity again? The answer is cataclysmic. The simple act of standing up upon return could cause the skeletal system to fracture under the sudden, heavy weight of 1 g. The heart, now a shadow of its former self, would likely fail to provide enough oxygen to the brain, leading to immediate collapse. Before we even consider the radiation or the cold, we must accept that the voyage itself rewrites our biology to favor the destination, at the total expense of the home we left behind. But the physical decay is only the first domino. Where are you watching from today? If these cold realities of deep space fascinate you, consider subscribing to join our exploration of the quiet truths of the cosmos. Even if we could somehow reinforce the skeleton, we cannot shield the delicate circuitry of the mind. Beyond the Earth's protective magnetic envelope, space is filled with high-energy galactic cosmic rays. These are not like the ultraviolet light that gives you a sunburn. These are heavy ions traveling at nearly the speed of light. They act like microscopic subatomic bullets, tearing through aluminum hull plating and eventually through your skull. Mars has no global magnetic field and an atmosphere less than 1% as thick as ours. Living there is equivalent to receiving a full-body CT scan every few days, indefinitely. While the risk of cancer is the most common concern, the more immediate threat is space brain. Recent studies on rodents exposed to simulated cosmic radiation revealed significant inflammation in the brain's neural pathways. This leads to memory problems, slowed thinking, and a permanent difficulty in making complex decisions. Imagine being a pioneer responsible for maintaining life support systems while your ability to solve basic problems is slowly being erased by radiation. This isn't a hypothetical fear, it is a cumulative certainty. After 18 months on the surface, the neurological damage could be irreversible. We are talking about the physical destruction of synapses, the very connections that hold your personality and skills together. This constant bombardment is happening while your vision is simultaneously failing. In microgravity, fluids in the body shift toward the head, increasing intracranial pressure. This pressure flattens the back of the eyeballs and inflames the optic nerves. Over long durations, this causes permanent blurring and vision loss. You would be living in a world of red dust that you can no longer see clearly, with a mind that can no longer process the crisis. That cognitive decline would be enough to end the mission for most, but the true finality comes from a chemical reality hidden in the soil itself. The very ground of Mars is toxic. The Martian regolith is saturated with perchlorates, salts that are highly hazardous to human biology. On Earth, these chemicals are used in rocket fuel and fireworks. On Mars, they are everywhere.
Despite our best efforts at airlocks and dust-off protocols, Martian dust is famously invasive. It is electrostatic, clinging to suits, boots, and tools. It will inevitably enter the living habitats. Once inhaled or ingested, perchlorates attack the thyroid gland. They prevent the body from absorbing iodine, effectively shutting down the production of hormones that regulate metabolism, body temperature, and heart rate. This chemical poisoning compounds the physical atrophy we discussed earlier. While your bones are thinning and your brain is slowing, your endocrine system is being systematically dismantled by the soil beneath your feet. It is a triple threat of biological failure: skeletal collapse, neurological decay, and chemical toxicity. The math of survival becomes a countdown. We can send enough oxygen, we can manufacture enough water, but we cannot manufacture a new human body that is immune to the environment it evolved to survive in. We are creatures of Earth, fine-tuned over millions of years for a specific pressure, a specific gravity, and a specific radiation level. Mars is not a second home. It is a biological incinerator. The one-way nature of the trip isn't a choice made by mission planners in a boardroom. It is a choice made by the cells in your body. They adapt to Mars because they must, but in doing so, they burn the bridge back to Earth. You don't return from Mars because by the time you're ready to leave, you are no longer a creature that can survive on the planet you originated from. There is a hidden biological dimension to this journey that we rarely discuss: the invisible war within. Even if we could engineer solutions for gravity, radiation, and toxic soil, we are still tethered to Earth by our microbiome. We are not solitary individuals. We are walking, breathing ecosystems teeming with trillions of bacteria. On Earth, this internal, microscopic world is kept in a delicate, symbiotic balance by a vast web of environmental factors, competition with other microbes, and the constant training provided by our planet's diverse biosphere. On a sterile, isolated planet like Mars, this balance is shattered. Within the artificial, closed-loop life support systems of a Martian colony, our own internal bacteria would face no external competition. Deprived of the natural checks and balances of Earth, these microbes could undergo rapid, unpredictable mutations. The very bacteria that currently sit quietly in your gut, helping you digest food, could evolve into aggressive, opportunistic pathogens. In the high-stress, high-radiation environment of a space habitat, your own biology could effectively turn against you. Simultaneously, the human immune system would begin to drift into a state of evolutionary amnesia. Our defenses are honed by daily exposure to a messy microbial world. Without that constant stimulation, our immune response would likely grow weak and confused. Returning to Earth wouldn't just be a matter of surviving the physical weight of gravity. It would be a profound biological shock. To a returned Martian colonist, a common cold or a mundane bacterium found in backyard soil wouldn't be a minor nuisance. It would be a lethal threat. You would be returning to a homeworld that is now biologically incompatible with your existence. We often frame the mission to Mars as a grand adventure, a natural sequel to the Apollo moon landings. But the moon was a 3-day journey, a brief camping trip in the cosmic backyard. Mars is a life sentence. The realization that you will never again feel a natural breeze, never smell the scent of rain on hot pavement, and never walk a single step with the mechanical hiss of a pressurized suit is more than a mental burden. It is the final resolution of the Martian experiment, the total isolation of the human animal from its evolutionary cradle. The human spirit is undeniably resilient, but the human vessel is incredibly fragile. We are bound to our homeworld by ties much stronger than the simple pull of gravity. We are woven into Earth by the very way our blood pumps, our synapses fire, and our cells interact with the world around us. To leave Earth forever is to do more than move to a new planet. It is to leave behind the very environmental context that defines what it means to be human. Once that cord is cut, there is no going back. The Red Planet is a beautiful silent tomb. We may go there, and we may even thrive there for a time, but we will do so as a new, different kind of being. The Earth will remain a bright blue memory, a world we can see through telescopes, but one we can never again touch.